Okay, so let's look at another example of a series combination circuit. So in here, we're going to measure the total resistance between points A and points B. And if you'll notice, we have R1 in series with R2. So if we just look at these two here, so straight path, one through there, R1 and R2 are in series with one another. We got R1 plus R2. And then they're in series with these two, but R3 and R4 are in parallel with each other. So we've got R3 is in parallel with R4. But these two are in series with the others there. So the equivalent little formula here is going to be that R1 is in series with R2 in series with the parallel combination of 3 and 4. So 3 and 4 are in parallel, and then the rest are going to be in series. And then what we're going to do now that we have this is we're going to break this down and see what the total resistance is going to be. So the first thing we're going to start with is right here. I can't do the series of this because I have multiple combinations, but these two are in parallel if I just look at them by themselves. So if we look at just this point here, let's throw this in there as point C. We're going to look between C and B. So this should look familiar as a parallel circuit between nodes C and B with 220 ohms and 330 ohms. So this becomes a simple equation. So the total resistance in parallel is 1 over the reciprocal of the two values. So 220 plus 1 over 330. Gives us an equivalent value of this circuit as being 132 ohms. So now we can consider this to be the equivalent of these two. So we can collapse this down. And effectively what happens is we can treat it. I want to erase them so you can still see the numbers. As if this had a single resistor of a value of 132 ohms. We found the equivalent resistance of these two branches. And now we have 100, 100 in series with 132. And that becomes pretty simple because the total resistance in series, just in case you're looking at formulas, this is the parallel total resistance. Series total resistance is the sum of all the resistors that are in series. In our case, we have 100, 100, and 132. So 100 plus 100 plus 132 for a total of 332 ohms. Total resistance for the entire circuit. So we found our smallest branch that only had either a series circuit or a parallel circuit. In this case, it was the 220 and the 330 in parallel with each other. We used the parallel total resistance formula of 1 over the reciprocal of the values, and we got a total resistance of this portion to be 132 ohms. So then we treat the circuit as if it was one resistor of that equivalent value in place of these two. And now we have a single path through this resistor, through this resistor, through this resistor to point B. So that's now a series circuit of 100, 132, which gives us a total resistance of 332 ohms.